Hey, welcome back on the Fibrous Malachite part 2. Today we're gonna talk about the procedural rock base that will support our crystal. Let's dive in. So that was the crystal we made. Let's create another geocontext that we're gonna call rock base and dive inside. So we're gonna start by dropping a circle and orient it in the proper way. So that would be ZX plane. And well, we need to switch the type to polygons and add some more divisions. All right. I'm going to use a polyframe to reorient the normals and also a transform. So first, the polyframe, we need to set the normal as a tangent name. And as soon as we do that, now with the mountain, we can deform the circle with some very fractal shapes. So that's pretty cool. And I kind of like to tweak the scale Z to stretch it a bit more. And of course we can resample the circle so that we got more points. Now it's mostly a matter of playing with the mountain and trying to find a cool balance, I guess, in terms of breakups and stuff. So we can play with the roughness, element size, and the height to get different results. And also the resample is gonna play a big role too in that look. We could also try to tweak the noise type and change it to find some more interesting result. Right now I'm not sure it's really making it better, but let's keep going for now. We're going to create a remesh node just so we have a proper mesh with triangles. And yeah, let's play a bit more with the mountain. We're going to try the purlin. And after that, we can basically play with deformers to make it less flat. So bent would be one way maybe to give some interesting deformation. So the capture length may be not enough. Yeah, we'll see. Maybe something like that, something very subtle. And after that, we can pretty much drop another mountain. And maybe let's increase the element size to get broader noise variation and decrease the roughness so that there's not too much tiny detail going on. So then we can try the poly extrude, and we're gonna set two different values of extrude, kind of like what we did with the explode view in the previous parts. And we're gonna blend that with the breakups node that we created before. So I got another display bugs, looks like a display bug. So let's go back to the object and come back, and it's fine. So I'm gonna copy the edge breakups that we created, and let's connect that to our extrude. So it's not doing much because we would need to tweak a bit more. Few things like the mesh, it's probably not dense enough. Like we start to see variation appearing now, and let's play with the contrast of that turbulence. Of course, yeah, we can always increase the extrude to make it more extreme. So from there, I'm adding a VDB from polygons so that we can remesh this thing a little better with some voxel. So I'm switching the convert to polygon then, and that's what we got. So I'm gonna go back to the main mountain that we created and just make it simple with height at 1.53 and element size to 0.64. And let's try to fuse some point actually. This way we can see that it's making the whole thing a bit more simple, really. We are losing some points, but on the other hand, it's doing a pretty nice job at creating some broad shapes, and yeah, I'm kind of happy with that. So the mountain could be probably more interesting. I'm not sure about the bend, so I'm gonna leave it disabled for now. And let's try to offset the noise. If we, yeah, something like that. Yeah, we definitely get some more interesting shape. Could add some more resolution by decreasing voxel size. So it's looking much sharper. It's like almost too sharp now. So I'm probably gonna drop a subdivide node after the edge breakup so that we can control a bit the smoothness and try to get something a little, yeah, not that blobby though. We still want to keep some sharp feature. So I'm playing with the crease weight to balance it out. I think 0.7 is a good balance. And we could add another mountain just after the subdivide. Try to get some interesting breakups. I'm actually going to increase subdivide depth to 2. Yeah, the danger is kind of to get something too blobby. So I'm playing with the crease weight a bit more. That's looking alright. I think from here we should also subdivide the mesh. So if we do that on that side, let's not forget to do the same on the other extrude so that we get the same number of points. Bloop. So we start to see more details going on. That's pretty cool. Let's make sure to copy the parameter of that guy onto the other one and paste it as relative reference so that if we change that to 0, 1, 2, it's also changing the subdivide 3. I'm going to tweak a bit more the edge breakups. Yeah, something like that's pretty cool. I'm adding another mountain node on top after the VDB, but this time we're going to try to get a streaky pattern on the borders so that it's not so flat and sharp. So right now it's just a mess, but let's reduce the height and probably play more with the scale Y, like so. Yeah, we getting some more interesting breakups, I think, on the sides. And let's reapply some VDB on top. This one's going to be sharper if we decrease the voxel size. That's pretty cool. So from here, we're going to create a null that we're going to call output rock base. And that will be the export on which we're going to create some attributes and whatnot. So I'm going to export that with another rope geometry and call that rock base. We can, of course, change the adaptivity inside the convert VDB so that it's not so dense in terms of mesh faces and so on. So that's looking a bit better in terms of optimization. Let's save to disk. Right. Now we're going to add another VDB treatment on top to make it even more high res. So let's drop a VDB from polygons. And this time we're going to, well, first set a very low voxel size. And we're going to use the fog VDB instead of the distance VDB. Let's check fill interior, and we're going to drop convert VDB. So in that situation, we actually need to play with ISO value in the convert VDB to remesh the geometry. And I'm creating a volume VOP. Inside, I'm going to create a unified noise static and plug the position to the pose input of the unified. And let's multiply it with the current density. So I'm setting the noise tab first to Worley Cellular F2 minus F1, set a frequency around 10. So I'm adding a fractal standard FBM and decreasing the roughness so that it's not too noisy. All right, let's promote some parameters to make it more user-friendly. And let's actually decrease fill interior so that we got a nice pattern going on. And so the cracks doesn't look too deep. Can try to increase the roughness and play probably more with the frequency too. Yeah, and actually we might need to export some gain parameters, and as soon as we increase it, it should affect the depth of the volume. So I promoted it so that we can control it right at the root of the volume VOP. And yeah, I think it's looking much better. So we're gonna export that guy, creating a null we're gonna call rock high res. And let's copy paste the rock geometry that we had, and we're gonna call that rock high res. And change the adaptivity again to optimize the mesh. We're gonna create some network box to organize a bit. So I'm gonna put that in red since it's the high res, and save to disk. So one thing we can do to optimize the setup is to create a switch. So we're gonna call the geometry rock base by copying this parameter and paste it into a file. Like so, and create a switch node. We're gonna call it switch to bakegeo and call the file name rockbase. So if we set the switch to 1, it's basically gonna apply the VDB treatment onto the baked geometry, and it's not gonna compute all the graph above. So that's pretty much it for this part. I see you guys in the next one.